Hello, my name is Mr. A, and today we're going to talk about geometry. Well, okay, I guess when I'm talking about geometry, I actually mean area of parallelograms. So for starters, I went ahead and drew out 3 parallelograms, a square, a rectangle, and the stereotypical parallelogram. And we're going to work on finding the area of them. Now, a parallelogram is going to be any 4-sided shape in which all 4 of the sides have a parallel partner. For example, if these 2 lines went forever in each direction, they would never intersect. Same with these set of lines. The same is true of a rectangle. This will go on forever, this will go on forever, they won't touch. And last, this shape right here will also go on forever in each direction, and their pairs will never cross. So, for starters, let's figure out what the formula is for the area of a parallelogram. The area of a parallelogram is found using the formula area equals base times height. And it's written out just like this, with capital A representing area, the B representing the base, and the H representing the height. So let's start by finding out what the dimensions are of this square. The square has a base of 4 units, and the height, because it is a square, also has a height of 4 units. When you do 4 units times 4 units, you will get 16 units squared. There we go. Now, the reason we do multiplication is you could do this a little bit slower, and that would be by counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 squares inside of this shape. Rather than counting it out, though, you would simply multiply each side, and that gives you the same amount. Moving on to the rectangle, which has a base of 2 units and a height of 1, 2, 3, 4, 5, 6, 7 units. Doing 2 times 7, that will give you an area of 14 units squared. Moving on to the last shape, we have this parallelogram. Now this one is a little bit trickier because, well, that is not an exact measurement. The diagonal line can't be used for finding area. In fact, let me write that down off to the side because that sounds really important. Never, ever, ever, ever use the diagonal. It would help if I knew how to spell the word use. Never use the diagonal. For area. Now, for perimeter, you will still use the diagonal, but for area, that's not the line you're going to count. A lot of times, mathematicians will draw the height as a vertical dotted line, cutting off this little triangle piece, and indicating that this is vertical by adding a right angle. Now, we count out the base, which goes from this corner all the way over to this corner. 1, 2, 3, 4, that is 5 units. And a height, which is going to be 1, 2, 3 units. So, once we have the base of 5 and the height of 3, we will know that the area is whatever 5 times 3 is, which is going to be 15 units squared. Okay? Now, if I didn't use this grid paper, and I were to instead switch to, let's say, just a blank little sticky note, that would become a little bit more, how would we say, challenging. Just because with a sticky note, we don't have those grids. We have to be told what the dimensions are. So if I drew another square, or as close to a square as I can, I could say that the base of this square would be, we'll go with 5 inches. The height must be 5 inches since this is a square. And I'll indicate that it is by drawing these little 90-degree marks. We would do 5 inches times 5 inches. And the area would equal 25 inches squared. Now, if we went ahead and did, say, a parallelogram, I'm going to try to trick people, and I'm going to write that the base could be 12 feet. I'm going to mark that this side piece is going to be, we'll say, 4 feet. And I'm also going to draw a dotted line way over here, and I'll label this 3 feet. Now, if you look over here at this note, it gives a pretty clear warning about this particular shape, which is that we will never use the diagonal if we're finding area. So because that 4 is diagonal, we're going to put a mark through it, and we'll mark that it is a diagonal. That way, we're not going to get confused and try to use that once we try to calculate the area. So the area is going to be 3 feet times 12 feet, the base times the height, which will give us a final area of 36 feet squared. Okay? Let's go ahead and move on to something just a little bit more challenging, which would be the area of triangles. Triangles are not that much different. In fact, there's only one difference. The area of triangles is going to have one minor difference. The formula is area equals base times height divided by 2. Now this can be written a number of different ways. Another popular way people choose to write it is area equals 1/2 of the base times the height. What's important to understand is that there is no difference in these two formulas. They are exactly the same. If I were to do 2 times 3, which would give me 6, and then divide by 2, that would give me a final answer of 3. If I were to do 1/2 times 2, which will equal 1, times 3, that will also give me 3. It does not matter which one you choose, it is only a matter of can you recognize that these are the same. Let's give you some examples. If I started out with a right triangle, and I drew it just like this, we have to figure out what the base is. The base, that's pretty simple. It's going to be down here. 1, 2, 3. 3 units. The height is a little bit trickier, but it's easy to spot on a right triangle. The height is going straight up and straight down, and it has a height of 1, 2, 3, 4, 5 units. So we're going to use this formula. Area equals base times height. That is 5 times 3. So 5 times 3, that will give me 15 on the top. But then I have to do 15 divided by 2. Lucky for you, according to our standards, this happens to be calculator active. So you could use a calculator if you wanted to. If you didn't want to, then you could simply do 15 divided by 2. 2 goes into 15 7 times, which gives me 14. Add a decimal and a 0 to carry down. 2 goes into 10 5 times. Alright, and if you're the class that is with me in 2018, don't worry, we'll get to this very, very soon. But for right now, you need to know that 5 times 3 divided by 2 is going to give me an area of 7.5. units squared. Okay? Now this is a little bit more difficult than finding the area of a standard rectangle or a square, simply because you can't really tell exactly how much of a square each of these small sections are. This square has been cut off, so is this one, this one, this one, and this one. So yes, you could for the most part count out that there are probably going to be about 7 units, but without knowing the formula for the area of a triangle, it's almost impossible to just count. Let's move on to one more example. If I have a, let's say, isosceles triangle, and I drew this out more or less like that. Not a great isosceles triangle, but I am not an arts teacher, so there we go. If we did this, we would count out the base, 1, 2, 3, 4, 5, 6 units, and then we have to find the height. Now the height is going to be a little bit trickier because, well, unlike the right triangle, there is no straight vertical line. At this point, you have 2 options. The option which I would recommend, at least for isosceles triangles, would be to draw a line straight down the center and then indicate that it is a straight vertical line from the base using a right angle mark. Now you could count that vertical line, which gives me a height of 1, 2, 3, 4, 5, 6 units tall. Or, using that same method, you can draw a line on the outside of it. And I'm just going to indicate this line right here, and then count how tall that line is, seeing as the line is exactly as tall as the triangle. 1, 2, 3, 4, 5. Once again, it is 6 units. At this point, you're simply going to do base times height, 6 times 6, which gives me 36. Then you will do 36 divided by 2. 36 divided by 2 gives me a final area of 18 units squared. There we go. Now, let me give you one more example, going back to the sticky notes. If I brought back my sticky notes, and I decided to give you a triangle problem, this time, not being quite so nice, and this time giving you a triangle that has some values for its diagonals. We're going to have a triangle that has a base. We're going to do a isosceles triangle, or equilateral, or whatever shape this is that I happen to have drawn. And I'm going to give you a bunch of different values. I'm going to tell you that the base was originally going to be 8 inches. I'll tell you that this side was going to be 6 inches. And I will tell you that this side is going to be 7 inches. Now, if you look at this right now, there shouldn't be any way that you can give me the area of this shape. I have not given you a vertical line. I have not given you anything that you could use as the height, which is a problem. Now, I am also going to give you this. I will give you one vertical line, and I'm going to tell you that this is 5 inches. Now you should be able to find the area of this triangle. Now first, what I would want you to do is mark out your diagonals so that you don't use them. These would come in handy if you were asked to find perimeter, but not for area. 7 and 6 are both diagonal lines. They are not going straight up and down. They do not have a right angle mark. So, with a height of 5 and a base of 8, we will do 8 times 5, which will give me 40. Then we will do 40 divided by 2. 40 divided by 2 will give me an area of 20 inches squared. that is how that is to be done. Let me go over a couple of examples from a sheet that I gave some of my students to do. Starting off with this problem, it's just a word problem, a very short one, and it doesn't give us any sort of picture to go along with it. It just tells us that this is a parallelogram with a base of 1.5 inches and a height of 15 inches. Lucky for us, that's all we need. Using our formula, area equals base times height, we'll multiply 1.5 and 15. That's going to give us an area, using a calculator, of 22.5 square inches. Let's go on to number 3 since I can see it down here. It's telling us about a toy box that needs to be painted and that we need to know how much paint we need to purchase. So we have to find the area of this parallelogram, as it states right here. And it gives us 3 values, which is kind of unfortunate. Our formula only allows 2 values, the base and the height. So take a moment and look over those values and see if you know which one is the trick. Which one should we not use to find the area? Alright, that's enough time. The base is going to be 3 feet and it stretches across the entire shape. The height is going to be a straight vertical line, a line that goes straight up and straight down and is indicated with a right angle mark located here. Which means this is our real height, and this is our trick. It's a diagonal. That's not one that we're going to use. So, we just multiply 3 feet times 1.3 feet. 3 times 1.3 is 3.9. And last that I'll go over on this side says you need 24 square feet of a parallelogram-shaped pen for your pet bunnies to run around. So, for possible bases, possible heights. We need a base and a height that when multiplied will give us 24 square feet. I'm going to give you just one example, and that is a base of 6 and a height of 4. If I have a base of 6 feet and a height of 4 feet, that will give me a total area, 6 times 4, of 24 square feet. There are other pairs of numbers that I can use that will also multiply together to get 24. Flipping it over to the other side, we have triangles. Now, for the top part, we have a few different triangles up here, and it wants to know which of the triangles has an area of 6 square inches. So we'll start with section A. A has a base of 6, and it has a height of what appears to be 2. 6 times 2, using our formula, is going to give me 12. And then 12 divided by 2 gives me, well, 6. So I know that A is going to work. I can circle it. Option B. It's clearly too big, but let's make sure. It has a base of also 6 and a height, this time, of 4. Now 6 times 4, that's going to give me 24. And then 24 divided by 2 is going to give me an area of 12. So I'll just write that out so I don't forget. Area is 12, which is frankly too big. Triangle C looks like it had a bit of a misprint, but I can figure it out. It has a base of 1, 2, 3, 4, 5, 6, and a height of 2. Or rather, it's supposed to have a height of 2 and supposed to have a base of 6. So, using our knowledge of triangle A, the fact that it had a base of 6 and a height of 2, we know that triangle C is going to be exactly the same. And last but not least, triangle D. This is here for people who forget the formula. It has a base of 2 and it has a height of 3. Now, if you do 2 times 3, you will get 6 at first. And a few people will be tempted to say that it works for this problem. Unfortunately for them, there is one other part of this formula, which is to divide by 2. 6 divided by 2 is not still going to be 6, so it can't be triangle D. The very last problem I'm going to talk about is going to be this one. How much plywood would you need to build one triangular face for a skate ramp with a base of 10.5 and a height of 4 feet? So, if I plug that into our formula, that area equals my base times my height, and then divide it by 2, what would I get? I'm actually going to leave this problem here. I don't want to solve it. Alright guys, that's all for me today. Hope you found this informative, and until next time, see you later.